Welcome to Introduction to the 6 Basic Quadric Surfaces. The goals of this video are to define a quadric surface and also to give an example of the 6 basic quadric surfaces. After this introductory video, we'll take a look at each of the 6 basic quadric surfaces in more detail. A quadric surface is given by a degree 2 equation in the following form. However, in my set of videos, we won't be dealing with the rotation of these quadric surfaces, so we won't see equations with an xy term, xz term, or a yz term. The 6 basic types of quadric surfaces are the ellipsoid, the hyperboloid in one sheet, the hyperboloid of 2 sheets, elliptical cone, elliptical paraboloid, and the hyperbolic paraboloid. The degree and sign of the terms, as well as which terms are present, determine which of the 6 quadric surfaces is given. When it comes to graphing a quadric surface, it's often helpful to graph the xy, xz, and yz traces. These are the intersections of the surface with the 3 planes in the xyz coordinate system. To determine the xy trace, we'll set z equal to 0. To determine the xz trace, we'll set y equal to 0. And to determine the yz trace, we'll set x equal to 0. We'll take a look at this in much more detail in the next several videos. Here is the form of the quadric surface that creates what's called an ellipsoid. And here are the characteristics. All 3 degree 2 terms are present. All 3 degree 2 terms are positive when the equation is equal to positive 1. And all 3 traces are an ellipse. Let's take a look at another graph of this ellipsoid. Here it is again. If we take a look at it looking down on the xy plane, as we see here, we see the shape is an ellipse. If we take a look at it from the xz direction, it's also an ellipse. If we take a look at it from the yz direction, again, it's also an ellipse. So this is what we're talking about when we refer to the different traces of the quadric surface. This is the ellipsoid. Now let's take a look at the hyperboloid of one sheet. Here's the equation in the most general sense. Notice all 3 degree 2 terms are present. However, 2 of the degree 2 terms are positive, as we see here for the x squared and y squared term, but one of the squared terms is negative, as we see here for the z squared term. Now, it doesn't always have to be the z squared term that's negative, but 2 are positive and 1 is negative. For a hyperboloid of one sheet, one of the traces will be an ellipse, 2 of the traces will be hyperbolas, and the axis is parallel to the negative variable. So here we see a negative z squared term, and the axis for this is parallel to the z-axis. Let's take a closer look at this graph as well. So again, one trace is an ellipse, as we see in this case looking at the xy plane. If we take a look at the xz trace, it would look something like this. We can see the hyperbola here and here. If we take a look at the yz trace, in this case, it's also a hyperbola. This is a hyperboloid of one sheet. Let's take a look at the hyperboloid of 2 sheets. Notice all 3 degree 2 terms are present, but now 2 of the degree 2 terms are negative and only 1 is positive when the equation is equal to positive 1. So if we have 2 negative terms, it's going to be a hyperboloid of 2 sheets. And again, we have 2 traces that are hyperbolas and 1 trace that is an ellipse. Now the elliptical trace may not be in the exact plane, but it will be parallel to the 3rd plane. And the axis will be parallel to the positive term, meaning in this case the axis is parallel to the z-axis because the z term is positive. Let's take a closer look. Here it is. Notice the xy trace. We're looking down on the xy plane, we see an ellipse. Looking at the xz trace in this direction here, we see the hyperbola, as well as in the yz trace, as we see here. This is the hyperboloid of 2 sheets. Next we have the elliptical cone. Again, notice all degree 2 terms are present, where 2 of them are positive and 1 of them is negative, but now the equation is equal to 0. We have 2 traces that are hyperbolas and 1 trace that is an ellipse, and the axis is parallel to the negative variable. Here's the graph of the elliptical cone. Again, in this case, the xy trace is elliptical. The xz trace is a hyperbola, and so is the yz trace. This is the elliptical cone. Next we have the elliptical paraboloid. Notice now there are only 2 degree 2 terms and 1 degree 1 term. Here the z term is degree 1, but again it doesn't have to be the z term, it could be the x or the y term that's degree 1. 2 traces will be parabolas and 1 trace will be an ellipse, and the axis will be parallel to the degree 1 variable. Here's the elliptical paraboloid. Notice in this case the xz trace is a parabola as well as the yz trace, and the xy trace is elliptical. This is the elliptical paraboloid. And the last one we'll talk about is the hyperbolic paraboloid. Notice again there are 2 degree 2 terms where now 1 is positive and 1 is negative, and there's 1 degree 1 term. 1 trace is a hyperbola and 2 traces are parabolas, and the axis is parallel to the degree 1 variable. In this case the xz trace is the parabolic trace as well as the yz trace. Notice 1 parabola opened up and 1 opens down, and the xy trace, as we see here, is hyperbolic. This is the graph of the hyperbolic paraboloid. As I mentioned at the beginning of the video, we'll take a look at each of these individually in the next 6 videos. Thank you for watching.